Hello guys, welcome to another calculus video. Today we're going to be talking about differentiation rules. And differentiation is a word that comes from the word differential, and what it means, it's like the operation of taking a derivative. So the same way you could take some function and take the square root of it, you can also take the derivative, and that's called an operation. So the symbol for differentiation is d over dx. So d over dx of f of x equals f prime of x. So we're going to be using this notation today. So we're just going to talk about a few different rules that you can use, and these rules will be super helpful because they're going to help us, they're going to make it so that we won't have to use the definition of derivative. We can instead use the list of derivatives that we know and the rules to figure out new derivatives. So something that I do have to talk about is derivative tables. So in your calculus class, you're going to have to memorize all the basic derivatives. And from this video onward, in this video I'll include all the derivatives you need. But after this, and all the videos after this, I'll expect you to have them memorized or just know them. So I'm going to go over everything that you have to know. So first, we have polynomial derivatives. So this is stuff like x, c, and c is just a constant, so this could be 1, 2, 3, pi, e, whatever. And x to the n, which is x to just any power. Then we have algebraic and exponential stuff, like ln x, e to the x, log x, log base a of x, and a to the x, where again a is just some arbitrary base, which is a number greater than 0. Trigonometric, so this is your 6 basic trigonometric functions: sine, cosine, tangent, secant, cotangent, and cosecant. Right? Then you have your inverse trig, which is just the inverse of all these functions. So for example, inverse sine or inverse tan are going to be the big ones. We will see the other ones just a little bit, but mostly these two. And hyperbolic and inverse hyperbolic trig, chances are we're not going to need to know this, but this is stuff like cosh of x and sine h of x. I'm not going to include these without telling you what the derivatives are, because not many calculus classes actually require these ones. But without further ado, let's jump into some rules that we can use to get the derivatives of more complex functions. So this is the sum rule. This should be pretty straightforward and should make sense. The derivative of some function plus some other function is the sum of their two derivatives. So one way, I'm going to introduce some new notation that we're going to use, which is f plus g, d over dx, of f plus g. I'm just taking out the x's, equals f prime plus g prime. And this is going to be pretty easy. So this should be pretty simple. We're going to just do some examples here. And also we're going to talk about the constant multiple rule. So the derivative of a constant times some function is that constant times that function's derivative. Okay, now let's look at an example problem. So first, we're given that the derivative of sine of x is cosine of x, and that the derivative of cosine of x is negative sine of x. Let's find the derivative of this function. So, since we're going to use our sum rule, so we're going to say the derivative of this plus the derivative of this. So first, let's find the derivative of 3 sine of x. So the derivative of 3 sine of x is going to be 3 times whatever the derivative of sine of x, and we can see here that that's cosine of x. Then, again, using our constant sum rule, we're going to add negative 2 times the derivative of cosine of x, which is negative sine of x. Negative sine of x, and I'm just going to distribute, so we have 3 cosine of x plus 2 sine of x, and that's our answer. This is our last rule for this video because this is going to be a 3-part series with different rules for derivatives, but this is called the power rule. So we use this when we have x to any power, so this could be x or x squared, x cubed, even x to the 0 power, which is just 1. We're going to use this rule. So the derivative of x to the n is n times x to the n minus 1. So let's do an example first. So we have x to the second power. The derivative of this, in this case n is 2, so we're going to have 2 times x to the 2 minus 1, which is just 2 times x to the first power, which is just 2x. Let's move on to the example for the power rule. Okay, we're going to find the derivative of 4x cubed minus 2x squared plus x minus 1. Okay. So I'm going to just use our constant multiple rules and sum rules to figure this out. So this is going to be 4 times the derivative of x cubed minus 2 times the derivative of x squared plus 1 times the derivative of x minus 1 times the derivative of 1. Okay, so x cubed, let's look at x cubed up here. So d over dx of x cubed. So in this case, n is 3, so we're going to bring the power to the front because that's where n is, 3, x to the, then we're going to subtract 1 from 3, and that's squared. So this is going to be 4 times 3x squared. And now let's do x squared. So we're going to again bring the power to the front. 2 times x to the 2 minus 1 is just 1, so this is just 2x. Next for x, so this is just x to the first power, so we're going to do 1 times x to the 1 minus 1 is just 0, so this is just 1. And for the derivative of 1 can actually be written as x to the 0. So it's just going to be 0 x to the minus 1, which is just, in this case, just going to be 0, because the 0 will just cancel with everything. So our derivative for this is just going to be 0. So at the end, we're going to have 12x squared minus 4x plus 1. And that's our answer. All right, that's all for this video. This was a shorter video, but I will be releasing videos on the other derivative rules, which are much more complicated. So yeah, I hope you found this helpful. I'll see you in the next video.